Hello children, welcome to channel Sube. Children, today I am going to discuss question number 35 from the MCQ part of 2021 Physics New Syllabus paper. A monochromatic ray of light falls on the surface of a glass sphere with incident angle 60 degrees as shown in the figure. So this angle is 60. Refractive index of the glass is root 3. So this one is glass. This ball is glass. The total angle of deviation of the emerging ray from the sphere is first one 0, second one 30, third one 60, fourth one 90, fifth one 180. Children, let us try to solve this problem. You know, if a light ray falls on a glass surface like this with an incident angle, since this medium has higher refractive index than the incident medium, so this incident medium is air, so the refractive index is 1. You know, for air the refractive index is 1. So this one is, this root 3 is something close to 1.7. So this one is higher than the refractive index for air outside. So when a light ray is trying to enter a medium whose refractive index is higher, you know, it bends towards the normal. So this line is the normal to the surface at the incident point. So the incident direction is this one. Incident direction is this one. So it is heading this way. The incident ray is heading this way. So the incident direction is this one. So we have to consider that like this and show it using a dash line like this. So that is the direction of incidence. So the incident ray now is refracted and bends towards the normal. So this refracted angle is smaller than the incident angle. So therefore we can draw the refracted ray like this. So this angle is refracted angle. We know it is denoted by simple r. So this incident angle is denoted by simple I. So I is equal 60 degrees now. So what is this deviation? Deviation is this angle. Deviation is this angle. Deviation d1, let us say d1 for that deviation. So that angle is called deviation. So what is deviation? The angle between the direction of the incident ray and the direction of the refracted ray. So between those two rays, between those two directions, the angle is called deviation angle. So that we have to find out, however. And again, what happens at this boundary, again it tries to leave this medium, glass medium, and enter into this new medium, air. So that is called emergent ray. So to find out the angle of this emergence, we have to draw another normal to this surface at this point like this. So make it a dash line. So now the ray is bending away from the normal because it is going to entering a rarer medium than this one, because the refractive index is again 1 here, because this medium is air. So the emergent ray is like this. So this angle is, we have to find out that. So let us find out first. Before that I have to say there is another deviation, because this ray, this refracted ray, was directing this way before striking this surface. So it was going this way. So we have to make that direction, mark it as by a dash line. So now the new ray, that is the emergent ray, is going this way, heading this way. So there is an angle again. So this angle again we call the angle of deviation. So that we have to denote by d2. So 2 times this ray is subjected to deviate. At first it deviates to right side like this, and again it deviates to right side like this. So there are 2 deviations. So we have to get the sum of these deviations. But first of all we have to find out this angle, refracted angle, simple r. So now let us try to find out this refracted angle, simple r. So we can write n1 sin I, otherwise we can write just n equals sin I divided by sin r, sin I divided by sin r. Then we have to substitute this value. We are writing this equation to this point. To this point we are writing to this point. At this point the refraction occurs. So it is happening according to this equation. So we can write the refractive index for this n. So root 3 equals sin I is this 60 degree divided by sin r that we don't know. So now we know the value of sin 60 is root 3 divided by 2. So sin r here, root 3 is here. So now what we have to do, we have to simplify. We can write this divide by 2 at the denominator like this under the line. So sin r. Now we can cancel this root 3. What we do is we divide by root 3 both sides like this. Then root 3 times 1 times, so here also 1 times 2, root 3. So therefore we get 1 1 here, not 0. At the left side we get a 1. So now let us write the what is remaining. So now we have 1 equals 1 over 2 times sin r. So we have to take this sin r this way, because we are going to find out r, we have to isolate it. Then we get sin r equals half. That means r equals 30 degrees. You should remember these values. So now we know r is 30 degrees. So we can mark it here. Now deleting r equals, just magnify a little bit. So here r equals 30. Now we know that. So what is this length? The distance r. R means the radius. So this one also radius. So that means these two lines are equal. This one equals to this one. The lengths are equal. So since these lengths are equal, distances are equal, these angles also equal. Therefore we can mark this angle also as 30 degrees. since these legs are equal. Then what is happening here, at angle 30 degrees this refracted ray falls on this surface, so it must leave at a 60 degrees, because it falls at first it was falling on this surface at a angle 60 degrees, and the refracted angle was 30. So now the refracted angle is 30, so this emergent angle must be this one 60. You don't have to calculate it. This one is 60. Same 60 to 30, 30 to 60. That is due to the reversibility principle of light. If we reverse the incoming ray like this, it is going this way, but if we reverse it to this way, what happens? It exactly follows this incident line like this. So now the incident angle is 30, refracted angle is 60. So like that. So here since this incident angle is 30, so refracted angle should be 60. So like that you can assume that this one is 60. Without calculation you can do it. So now we have to find out the value for D1. So we can find it easily using the trigonometry that we know. So this angle totally is 60 degree. So it is front of this angle. So this angle totally must be 60. So what we need is this green color portion. So that we can write, therefore this red one is totally 60, so we can subtract 30 from that, then we get D1 as 60 minus 30. Like that we can find out the D1. Then here also, if we observed the angles, so this total one is 60, the blue one, this one is 60, totally it is 60. Then this red angle is 30. So it is exactly front of this one is then 30, this one is 30. So what we need is this green part, that is 60 minus 30. So D2 also 60 minus 30. So this value is 30. So here also 30. So we have to now add the two D values, because the first ray turned to right like this, and the second time it again turned to right like this. So therefore we have to add to find out the final D value. Deviation is 30 plus 30, then we get 60. So that must be the answer. Total deviation is 60. So this one is the answer, children. So let us check whether this one is correct. 35 the question number is. 35, the third one is the answer. Right, we have done it correctly. So I think you can understand this problem is not a big issue. That is how it should be done. So children, I have altered the question a little bit, because we have done a past paper. When you are sitting next time in the exam, so you get a new problem, but they make new problems just changing little bit the past paper questions. So therefore I change this one a little bit. The mediums I changed. So they had given previously the ball was made of glass, so now I change it. The ball is air, the block is glass, so that is the only thing I changed. So here the question is, a monochromatic ray of light falls on the surface of an air sphere which is placed in a glass block with incident angle 60 degrees as shown in the figure. Refractive index of glass is √3. The total angle of deviation of the emerging ray from the sphere is, there are answers. So you have to calculate now. You do it on your own without looking at the video after pausing it. So I will give you time, but I don't stay until you finish it. I give you about 10 seconds to pause the video. So now I will solve this. So let us suppose this refracted ray is leaving this surface like this, because it doesn't bend towards the normal as it was previously. Now it should bend away. So the direction of incidence is this way, so a little bit away from the normal. It should bend like this, because this one is a optically denser medium, this one is a rarer medium. Now you have to take the refractive index of this medium as 1, because it is air, it is an air sphere. So let us zoom a little bit. So this one is the refracted angle. So let us try to find the angle of refraction. So this one, simple r. The same way let us try to find out, because you know that should be, however that should be, we should know that to find out the deviation. Later we can find out the deviation after trying to find out this simple r, the refracted angle. So let us write here, instead of that previous equation, the Snell equation let us write now. N1 sin I equals into sin r, because otherwise you will get confused if you used the previous one. N equals sin I divided by sin r, because here you have to substitute 1 over n instead of that. Therefore I use this one. This one will not make any confuse to you. So therefore n1 is this one, and sin I is this one, the same side. So n1 is √3, sin I is sin 60, equals n2 is this one, sin r is this one. The angle and the refractive index at the same medium. So n2 is 1, then times sin r. Sin r we don't know. So √3 sin 60 is √3 divided by 2, as we did previously. So this one we don't want, sin r here. So √3 is 3 divided by 2 equals sin r. So we have to find out now r, 3 divided by 2. So that means 1.5. So you can find the angle of such a sine value, because the maximum sine value is up to positive 1. All others are 0.5, 0.6, like that, below 1. So the sine graph is like this. So the maximum one is 1. So here you have received 1.5. Therefore there is no value for R. R has no value. So what does it mean? The meaning of that is the ray is the ray is subjected to total internal refraction. So you can write like this and take your decision. So that means total internal refraction is occurred here. So that means there is no ray like this. So let us get a copy, and now we can delete this angle is not exist. This angle is not exist, so is this ray. So we can delete it. Therefore, now we know what happens. Total internal reflection, not refraction here. This one should be reflection. Total internal reflection. That means totally the ray is reflected like this way up to here. So the angle must be, now the reflected angle must be same, the 60 to 60. So this is what happened. So now we have to find out the deviation. So the incident direction is this one, dash line. So what is the deviation? The angle between the incident direction and emergent rays. The directions are the angle between the direction of incident and the direction of emergent. So this one is the D. How to find out this? So this total angle is 180. We can subtract this one totally, how much? 120, 60. So if we subtract it, we get D. D equals 180 minus 120. Then we get 60 as the answer. So in this question also the answer is 60, but the way we solved is different than the first one. So the answer is 60. So let us go to another target question again. So now children, I have designed another target question for you. So I have altered a few things. You can try this. A monochromatic ray of light falls on the surface of an air sphere which is placed in a glass block with the incident angle 30 degrees. So I have changed it from 60 to 30 as shown in the figure. So like this. Refractive index of glass is root 2. Root 2 is something like 1.4. So that can be practically because glass, the refractive index of glass is 1.5. So it differs downwards and upwards little. So the total angle of deviation of the emerging ray from the sphere is so their answers. So you try to do this without looking at the video after pausing it. So you can try it and after that check whether you are correct. So I think now you have finished. You have taken your answer. You have reached to your answer. So I am going to solve it. So let us do n1 sin I as previously, n2 sin R. Let us first of all find out the value of R. Let us suppose the ray, the refracted ray is going like this, this angle is the refracted angle R. So n1 is root 2 now, this one, and angle is sine 30 equals n2 is 1 because this one is air times sine R. So sine 30 is cos 60, that is half. So you should remember these values. Then sine R. Then you can write root 2 here at the denominator. So sine R. So 1 root 2 is cancelled. So 1 over root 2 equals sine R. So what is the value? You should remember this also. If the sine R equals 1 over root 2, then R equals 45 degrees. In mechanics, you learn these things. Therefore, you should remember that to use in this lesson light. The angle is now 45. So we can follow the same path as previously. It is not subjected to total internal reflection. It doesn't reflect. It refracted. It gets refracted like this. So this angle is, now we know, 45 degrees. So the deviation now, it was heading this way, the incident ray, like this, dashed lines, heading this way. So what is this angle? Deviation angle is this one, 45 minus 30. 45 minus 30, this angle is 45 minus 30. So we get d1 equals 45 minus 30, that means 15. Then we have to draw the normal to this place to find out where it goes. So the emergent ray must bend towards the normal, because this one is the denser medium, this one it came from the rarer medium, so it should bend like this. So the angles, since these lines are equal in length, equal lines, radius, so therefore this total angle is same as this one, 45. Then came at 30 and left at 40, so again came at 40, so this one is going to be therefore 30. Refractive index equal, therefore indices are equal, therefore angles should be equal. Then the deviation here, how to find out? We have to draw the incident ray was heading this way. Now the incident ray is this one. Incident ray is this one now. So it is heading this way. So the turning is this one. The emergent ray has turned this way. This is the angle that we want. So that is d2. How to find out? This total angle is 45. So this one, then 45 minus 30. This upper angle is 30. this one is 30. So you can subtract, then again we get 45 minus 30, that is 15. So 15, 15. Let us check whether it is to the same direction or opposite. So this time the direction was left, like this. It came like this and bent to left. Now it is going this way, the blue line. Left 15 degrees, again left 15 degrees. So we have to get the sum. So final D is therefore 15 plus 15, so 30. So in this question the answer is 30, this one. So I think children, you can understand that we have to do that sort of exercises. So children, I think you are happy because I did 2 target questions, and also I solved the original MCQ problem. So if you are happy, please subscribe my channel, but don't subscribe twice. If you already have subscribed it, don't subscribe again, because then it will be cancelled. Then watch my videos again and again. See you tomorrow. Goodbye. Remember, you don't have much time.